So while learning the energy sector and understanding it well, why not build something with the help of? So I tried that. There's a website which is called Loveable app, which as per internet, it helps creating websites in seconds. So I gave a prompt. The prompt which I gave is the hi, help me build a website where it is the tool around energy sector and power generation point of view, majorly focus on turbines, where a user can select the megawatts what is required and followed by the place in India, particularly India, and help me give me the combination as of steam turbine, gas turbine, solar and the battery storage and show me the rough layout. And I use the free version of this Lovable app to just to have a test, and what solution it gave is mind blowing, and it has a lot of learning. And if someone like me who always like gave a understanding that think big, and one thing can come from this. So I gave a prompt, it took roughly 23 seconds, 30 seconds, and it gave me that version 1. So I'm sharing the version 1 and let me know if you have any comment, feedback, and feature down. So here we deep dive. So after that command, what came out is a clean layout in the dark where my user can enter how much megawatt is required in the 100, 10, 50 to 50 with the common ranges available till 10, 5 gigawatt. Now, along with that, the user can pick a state, and followed by the state, there is something called what is the solar capacity kilowatt hour meter square per day availability. And this is the data from Indian Energy Statistics, that Indian Energy is there, and I believe it is the latest data since I'm spending time on this. And we can pick what you want and generate the power mix, and it will give you. So let me take one example where Bangalore, where I'm residing. It gave me output. How much is my roughly cost? It will come around 734 crores. How much would be my plant load factor? Plant load factor is mainly the gas turbine and steam turbine combination. It is coming to 61.4%. And you see the carbon emission, which is like 425, and land requirement, if you say 5 liters per. Now, why it is that? So if we come down to the energy, if you see that the steam turbine requirement is roughly 70, solar is 24, 6 is gas, and 6 is battery storage. Now it looks this data is weak, but if someone has spent time in understanding the Indian energy market, you know the data will come around, the output energy mix will look around that. Now coming back to the process, again the same, it will go to my step up transformer where my 400 kV transmission, which is standard for any Indian standards, as well as it will go to my circuit breaker, bus bar, and protect. It can give the details of what technical details I needed. It can do that. And this is the 100, which is the grid promise, grid to stability. I have to give 100 will be there in the grid point. If you see, my solar availability is this much, 5.4, and Karnataka doesn't have major gas reserves. So my gas supply is land is medium because it's on a mid-size availability, and coal supply in India. So that's why my cost is on the higher side and land. Now let me pick one of the state, let's say in Bihar, where my solar availability is around 4.7, which is less than Karnataka. So if I click that, my cost is shoot up. My land area is less because I don't have, if I know my solar per day is 4.7, I'm not going to invest more. And my carbon emission is going to higher because I'm going to spend more on steam turbine and gas turbine. Based on that, my plant load factor will also, my water requirement is also has shoot up. So this data accuracy point of view, I believe it's for the amount of time I spent in reading the documents, it is on the closer to the right value. It is not hallucinated data, it's on the right side. Same. Now, if anyone who has been in, there are certain challenges, which is from, especially the land is low. So if we come here, this data is available in Indian Energy report, and gas supply is low. My coal supply is also low. Bihar coal supply is comparatively low. Getting that land is also hard. So that's why it's a challenge to, if I want to develop 100 megawatt and where to proceed, this challenge is there. Now let me take one more example, and we're going to have a small. So one more example. I'm gonna go, which is one of the top two states in India which is producing highest number of renewables, and we'll see now why. First of all, they have 5.8, which is more than Karnataka and way more than Bihar. Now, in this, my cost will come down because I'm going to invest less on my steam turbine and gas turbine. My cost has came down. Plant load factor come down to 50% because of more availability of solar in that region of Gujarat. I have low plant load factor, as well as my carbon emission will come down because I'm going to use less of the steam turbine. I'm going to use less steam turbine megawatt. So my carbon emission is low, but my land area is increased. Will be compromising. My land requirement will come with a lot of challenges which we are not aware at the then if steam reliability is less, so I need less watt, that is solar. Now this is my energy mix where 42 is available more, so I can go up to 40. So 25 to 35% is the battery storage, so it will come around 14%, and then I'm going to have the mix of these two, 42 and 18 megawatt. This combination can vary, but this is operational practice of the available market. We can spend time in each segment to get more accurate data. Right now, this website is built on free and internet available data only. So that is there. Now coming to the Gujarat gas supply will be on higher side because we all know one of the refinery which is in Jam, and so my gas supply won't be a problem. So gas supply is high. Land policies and the state policies are easier to purchase land from the to get a land for energy. So my land is on higher side. Coal supply is medium because it's a bigger state and the revenue is close to 1 trillion point of view if you consider that. So coal availability is also there. So if someone wants, like, let's see, I want to build something, a factory or something industry point of view, which I need to choose, and I need say 100 megawatt of my energy, and I'm going to invest that money to get the output of 100 megawatt. Simple. Now based on, and I'm going to push renewable so that I get the carbon emission credits, and it will help me save money in the taxes, and these are the available. Let's move up, let's go to Punjab. If I see Punjab, my cost is more, land is less, solar is less, carbon emission more, plant related factors, so I need more water, correct? And if you see gas supply is available, we have one gas supplier there in Punjab, and this is the data which is availability and easy. Now you can also play around with, you can also check the website which is built, and let me know if you have any comment, and it's fun and easy. Maybe in the next video, either I'm going to add one more version which detail of wind turbine availability, and I'm going to pick one of the one which is either steam turbine or gas turbine to make the process flow diagram for one particular segment, which will help you understand how much timeline is required. A typical steam turbine gas usually takes 7 years, 5 years, sometimes with the delays of infrastructure, policies, regulation, it goes beyond 10 years. So we're going to have one more case study around that in the next video. Meanwhile, check out the link and check out the website link in the comment section and let me know what do you think. And yeah, thank you.